Welcome to the next session. We discuss classroom workbook. Question number 13. Two dice are thrown simultaneously. The probability that the sum of numbers on both exceeds 8. When two dice are thrown, two outcomes will be there. Each outcome will be treated as a single ordered pair, right? So I can treat an outcome like this, A comma B. So this is first outcome and this is second outcome. So you need to add both the numbers. So this sum, the sum of A and B must exceed 8. Now let us see. So the probability that the sum exceeds 8. Sum exceeds 8. That means the sum can be 9 or R means plus. It can be 10 or it can be 11 or it can be 12 because the maximum sum is 12. Maximum sum is possible when both the outcomes are 6 and 6. So sum is greater than 8. So it can be 9 or 10 or 11 or 12. So R is replaced by this plus. Now let us see how many cases are required to get sum 9. To get sum 9, the required number of sample cases is like this. So 5, 4 is one case. 4, 5 is one possible case. 6, 3 is one case and 3, 6. So in this case, sum is 9. Now if you want to get sum 10, the possible cases are 5, 5, 6, 4, 4, 6. In this case, sum is 10. Now if you want to get sum 11, the possible cases are 5, 6, 6, 5. In this case, I will get 11. 5 plus 6, 6 plus 5. To get sum 12, I have only one case, that is 12. So in this case, only one chance, right? So in this case, sum is 12. So here, how many chances are there? 4 cases to get sum 9. 3 cases to get sum 10. 2 cases to get sum 11 and only one case to get 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, but totally this is 10 by 36. But to get sum 9, it is 4 chances. So 4 out of 36. Sum 10, 1, 2, 3. 3 out of 36. Sum 11, 2 chances. So it is 2 out of 36. 12 means only one chance. So therefore, this is 10 divided by 36. So option D is right answer. Question number 14. Very interesting question. In rolling of 2 fair dice, the outcome of an experiment is considered to be the sum of the numbers appearing on the dice. The probability is highest for the outcome of blank. I repeat the question. In rolling of 2 fair dice, the outcome of an experiment is considered to be the sum of the numbers appearing on the dice. So when you roll 2 dice, 2 outcomes will be there. Add both the numbers, you treat that outcome as a single outcome. Okay, that sum as single outcome. So the probability is highest for which outcome? So they were not asking probability of an event. For which outcome there will be highest probability. For which outcome there is highest probability. Let us see what are the possible outcomes when 2 dice are thrown if the sum is taken as an outcome. So what is the least possible outcome? 2. Least possible outcome will be obtained when least number occurs on one die and least number occurs on the second die. Least possible number on each die is 1, 1. So add the 2 numbers, you will get 2. So the least outcome in this experiment is 2 and the highest outcome in this experiment is 12. Okay. So let us have random variable. So the sum can be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is possible outcome. So actually 2 is sum of numbers appearing on the dice. So 2 to 12 you will have different outcomes. Let us see the probability in this case. So 2 is possible in case of 1, 1. So in this case only one chance out of 36. Now 3 will be possible in 2 cases, 2, 1 and 1, 2. So 2 chances out of 36. Now when you go to 4, you will get 3 chances, that is 2, 2, 3, 1 and 1 comma 3. 3 chances. So therefore this is 3 out of 36. Similarly, when you go to 5, you will get 4 by 36. For this 5 by 36, you can verify easily. So for 7, this is 6 by 36. For 5, it is 5 by 36. This is 4 by 36. Now decreasing starts. 3 by 36, 2 by 36, and this is 1 by 36. You can verify probabilities like this. So to get sum 2, we have only one possible case, 1 out of 36. To get sum 3, 2 chances, 2 plus 1, 1 plus 2, 2 out of 36. To get sum 4, 3 chances, 2, 2, 3, 1, 1, 3, 3 out of 36. Like this, when you fill this table, the probabilities will be in this manner. So increasing starts, increasing will be like this up to 7, again downfall starts. So therefore in this at the point 7 we are having highest outcome. Therefore in this case the highest probability will be possible only for outcome 7. So in the blank you need to write the outcome 7. Hope you understand this. Okay, so note these points. The lifetime of an electric bulb is a random variable with a PDF f of x equal to kx square. So what is PDF? F of x equal to kx square, where x is measured in years. X is measured in years. If the minimum and maximum lifetimes of bulb are 1 and 2 years respectively, 1 and 2 years respectively, then the value of k is blank. So it is given to electrical students. So the probability question is given in terms of electric bulb. So the electric bulb, the lifetime of an electric bulb is a PDF given by this k into x square. K is some constant. So what is x? X is a random variable which is measured in years. Lifetime is measured in years, right? So minimum lifetime is 1 year, maximum lifetime is 2 years. In that case, what is k value? Now this is a continuous random variable because PDF is given in terms of a function, the variable x. Therefore minimum lifetime is 1, maximum lifetime is 2. Therefore integrate this function between 1 to 2, the result must be equal to 1. So this implies integral 1 to 2 k x square dx equal to 1. So this implies k times x cube by 3, limits are from 1 to 2 equal to 1. So this implies k into 8 by 3 minus 1 by 3 equal to 1. Therefore k times 7 by 3 equal to 1. Therefore the value of k is 3 by 7. So this is the value of k. Just apply validity of PDF, you will get this. Since this is a PDF, when you integrate from minus infinity to plus infinity, the result must be 1. But here minimum lifetime is 1 year, maximum lifetime is 2 years. So integrate this function between 1 to 2, the result will be 1. So in that case, the value of k is 3 by 7. Question number 16. Consider the function f of x equal to k into x minus square bracket x. This is integral part of x for 0 less than or equal to x less than 2. 0 elsewhere. The value of k for which the above function is a PDF of some random variable is. See here one function is given between 0 to 2. Here 0 is included but 2 is not included. So between these two limits, the value of f of x is k times x minus square bracket of x. Basically it is integral part of x. We had a discussion about this during differential calculus, continuity of a function, right? So this is integral part of x, step function. K times x minus mod integral part of x when x lies between 0 to 2. Outside the limits it is 0. Here k is some constant. So the value they were asking the value of k for which the above function is a PDF of some random variable is. Right. Suppose if it is a valid PDF, then when you integrate from 0 to 2, f of x dx must be equal to 1 because it is defined only from 0 to 2. But the problem is, what is the integral of square bracket x? there we have some difficulties. Okay, so we need to simplify this function so that it is flexible to get integral very easily. Got this point? So since it is a valid PDF, when you integrate this function from 0 to 2, the result will be 1. But what is the integral of integral part of x? It doesn't exist generally. But it can be possible if it is simplified to simple polynomial expression. Let us see. Now here I am redefining this function f of x equal to something if 0 less than or equal to x less than 1. Here x values are ranging from 0. X can be 0. If x is 0, what is integral part of x? 0. If x is 0.1, its integral part is 0. Up to 1, but here I am not including 1. From 0 to 1 only. So from 0 to 1, integral part of x is 0. See, very simple. What is integral part of 0? This is 0. Integral part of 0.1, 0. Up to so on, you continue this up to integral part of 0.99, this is 0 only. So therefore, when x lies from 0 to 1, but 1 is not included, its integral part is 0. So this will be 0. So therefore, f of x is k into x if 0 less than or equal to x less than 1. If 0 less than or equal to x less than 1. But in between these limits, 1 has to be included. But here I did not include 1. In the next iteration, I include 1. So this is if 1 less than or equal to x less than 2. So when you take 1, integral part of 1 is 1. Integral part of 1.2 is 1. Integral part of 1.3 is 1. So continue up to integral part of 1.9 and this becomes 1. Therefore, when x is starting from 1 but up to 2, 2 is not included, its integral part is 1. So this will be 1 only. Therefore, if x lies between 1 to 2, this becomes x into k into x minus 1. Now you can get the answer. Since it is a valid PDF, integral 0 to 2 f of x dx is 1. But the function has a split from 0 to 1 and 1 to 2. Therefore, this integral becomes integral 0 to 1 f of x dx plus integral 1 to 2 f of x dx must be equal to 1. So this implies integral 0 to 1. Between 0 to 1, the function is kx. Kx dx. From 1 to 2, this is k into x minus 1 dx equal to 1. Now let us simplify this integral. So the first integral is k into x square by 2. Limits are from 0 to 1. The second one is k into x minus 1 whole square by 2. Limits are from 0 to 1. So this result must be equal to 1. So therefore this implies k by 2. Here this is k by 2. So apply, this is actually limits are from 1 to 2. So apply upper limit 2 followed by lower limits. So when you replace 2 by 1, this becomes 1. 1 minus 0 equal to 1. So this implies k equal to 1. Therefore, the value of k in this case is 1. Only thing is we have a split the function from 0 to 1 and 1 to 2. So based on these calculations. So try to understand these calculations and try to understand this. So based on this, we have modified the function like this. Okay. So note these points. Suppose x is a real valued random variable. X is a real valued random variable. That means x is taking real values. What does it mean? X is a continuous random variable. Then which of the following values cannot be attained by e of x and e of x square respectively? Let me write the options. So 0, 1, B 2, 3, C 1 by 2, 1 by 3, and option D 2, 5. So which of the following values cannot be attained? Cannot be attained by e of x and e of x square respectively. E of x and e of x square respectively. Cannot be attained. Now let us see what is the equation connecting e of x and e of x square. What is the equation connecting E of x and E of x square? Variance value. So we have variance sigma x square is E of x square minus E of x whole square. We know that variance of any random variable is always non-negative. Now let us verify in which option the variance is becoming negative, right? Now this is E of x value, this is E of x square. So in this case, sigma x square is 1 minus 0 square. Anyhow, this is greater than or equal to 0. In this case, this is sigma x square is, this is E of x square. So 3 minus 2 square, we were getting negative variance. So we are getting negative variance in this case. Therefore, if this is expectation of a random variable x, in that case, E of x square cannot be 3. If this is E of x square, then this should not be E of x value. Okay. So therefore, E of x and E of x square should not be 2 and 3. So this is the required answer. Even you can verify this. In this case, my variance sigma x square is 1 by 3 minus 1 by 2 whole square. This is greater than or equal to 0. In this case, the variance sigma x square is 5 minus 2 square. This is also non-negative. So in option A, we were getting non-negative variance. Here also non-negative. In this case, non-negative. But only in case of option B, we are getting negative variance. Therefore, these two values should not be E of x and E of x square. So the required answer is B. Just we have applied this. Variance cannot be negative, right? So in this case, we are getting negative variance in case of option B. So if this is E of x, this should not be E of x square. If this is E of x square, this should not be E of x. Okay. So it's a really nice question. In a population of n families, %50 of the families have 3 children. 30% of the family have 2 children. And the remaining means 20%. So they have 1 child. 1 child. What is the probability that a randomly picked child belongs to a family with 2 children? So suppose there is some housing society. There are a group of families. So how many families were there? N number of families. Out of these n number of families, 50% population, 50% families have 3 children per family. Basically, that's the meaning. Don't think that when you take, for example, 100 families, so when you consider 50 families kids, they were not 3 children. They were actually, for each family, they were 3. So 50% family have 3 children, and 30% have 2 children, and 20% have 1 child. So when you select 1 child randomly from this group, what is the probability that the selected child belongs to a family belonging to 2 children? That means, what is the probability that a randomly picked child belongs to a family with 2 children? That means second category family. Now let us see, you can take n value anything. Suppose I am taking n value 100. N value 100. Therefore 50 families have 3 children. So therefore 50 into 3. So this is equal to 150 children. 30%, 30 means 30. So 30%, 30 families have 2 children. 30 into 2, so this is 60. Now remaining 20, they have 20 into 1. So this is 20. Therefore the total number of children is 150 plus 60 plus 20. This is 230. So therefore, in the overall group, there are exactly 230 children. If I take n value 100, you can take n value 10, 4, anything. But distribution must be like this: 50%, 30%, 20%. So if I take n value 100, my job will be very simple. Okay, you can take any n value. So n value is 100. 50% families have 3 children. Therefore, 50 families have 150 children. 30 families have 60 children. And remaining 20 families have 20 children. So total number of children is 230. You select one guy. So therefore the denominator probability is a ratio. So 230 C1. That fellow belongs to second category. But how many people are there in the second category? 60. So therefore you must select one from 60. So this is 60 C1 by 230 C1. So this is 60 by 230. So therefore the answer is 6 divided by 23. So option B is right answer. So it is purely based on combinations. Okay, note these points. So what it is, a hydraulic structure has 4 gates which operate independently. The probability of failure of each gate is 0.2. So 4 gates are there. So the probability of failure of each gate is 0.2. So P of 1 equal to, P of 2 equal to, P of 3 equal to, P of 4 equal to 0.2. So don't think that they are sample points. If you feel that they are sample points, when you add them, you won't get 1. They are not sample points. The probability of failure of each gate is 0.2. So this is not a sample point actually. Okay. But the probability of failure of each gate is 0.2. There are exactly 4 gates. 1, 2, 3, 4. Given that gate 1 has failed, comma, the probability that both gates 2 and 3 will fail. That means, see, gates are in sequential manner. This is gate 1. This is gate 2. This is gate 3 and gate 4. So here this is already failed. So in that case, what is the probability that both second and third gates will fail? So that means it is conditional probability. This is already failed. So probability of failure of second and third gates, that is P of 2 intersection 3 slash 1. This is conditional probability. Probability of failure of second and third gates when gate 1 is already failed. Conditional probability. Now this is by definition P of 2 intersection 3 intersection 1 divided by P of 1. This is E1, this is E2. P of E1 slash E2 is P of E1 intersection E2 by P of E2. But all the gates are operating independently. So that means this intersection becomes a dot. So P of 2 dot, P of 3 dot, P of 1 divided by P of 1. So this and this will be cancelled. This is 0.2 times 0.2. Therefore, this is 0.04. So therefore, option C is right answer. Note these points. 4 fair 6-sided dice are rolled. Fair dice means, so die is proper. So on one face you have single dot, on one face 2 dots like this, proper die. So it is not biased. The probability that the sum of the results being 22 is k by 1296. Then what is k value? So when you go for 4 dice, when you roll 4 dice, then what will happen is 4 results will be there. So add all the results. So the sum should be 22. So to get 22, the probability is k by 1296. They were asking k value. Actually, that 1296, the probability is this, k by 1296. This is the probability. Actually, this k is nothing but in how many ways the sum of the 4 results is 22 when 4 dice are rolled. This 1206 plus 96 is actually 6 power 4. When 4 dice are rolled, the total number of sample points will be 6 power 4. This is 36 into 36. So this is actually 1296. Okay. So we need to find k value. That means k is nothing but the required number of favorable cases where sum of all results will be 22. Now let us see. Suppose when you start with one outcome 1, least outcome. Suppose assume that remaining outcomes are maximum outcomes. One possible outcome is 1, rest of the possible outcomes are 6s. Then you won't get 22. So 1 should not be there. Suppose one outcome is 2 and remaining outcomes are maximum. So sum should not be 22. Here sum is 19, here sum is 20. If one outcome is 3 and rest of the outcomes are even though 3, you won't get sum 22. So therefore, to get sum value 22, the least possible outcome is 4. This is one possible case where sum is 22. So the possible cases are like this: 4, 6, 6. This is one case. Now rearrange, change the positions of 4. So 6, 4, 6, 6. So similarly 6, 6, 4, 6 and 6, 6, 6, 4. So these are chances. So actually these are outcomes on first die, second die, third die, fourth die. So these are actually permutations. So we got 4 chances. When you look at 5, so 5, 5, 6, 6. In this case also like this. But you can see how many chances are there by rearranging 5s, by relocating the 5s. Here we have actually, in this case, the total number of permutations is, how many symbols are there? 4 symbols. 4 factorial by, but 4 is repeated 1 time and 6 is repeated 3 times. So 4 factorial is 24, 3 factorial is 6, this is 4. The 4 chances are this. Similarly, when you go to this, the required number of permutations is, how many symbols we have? 4 symbols. So it is 4 factorial divided by, but 5 is repeated twice. So divided with 2 factorial into 6 is repeated twice, so 2 factorial. 4 factorial is 24 by 2 into 2, so 24 by 4, this is 6. Therefore, there are exactly 4 plus 6, 10 chances where the sum of the results is 22 when 4 dice are rolled. So the probability is 10 divided by 6 power 4. So this is 10 divided by 1296. Therefore, the value of k is exactly 10. The value of k is 10. Note down these points.